Hello friends, welcome to my YouTube channel Electric Bud. Today I am going to share you how to avoid or how to fix through-hole errors in Altium. So this is the topic for today's video, how to avoid through-hole pad errors in Altium. So I will show you what are the major two different types of through-holes which we are using in PCBs. So first one is non-plated through hole and second one is plated through hole. So non-plated through hole means you don't there is no conductive ring inside the hole, and in plated through hole there is a conductive ring inside the through hole, and this conductive plane will be connected to external or internal uh, tracks or planes in the PCB. Like this is for mainly for conduction, and this non-plated through hole mainly we will use for supporting for uh, mechanical parts like the mounting holes, or for some connectors we have to add this kind of non-plated through hole pins for through hole pads for supporting the mechanical pins in the connectors. So this is mainly for mechanical, that is for non-conductive application, and this is for conductive application, that is this will be using for active devices like this kind of through hole pins we will use in through hole lead capacitor, resistors and diodes, etc. And these type of non-plated through holes we will use for mainly for mechanical support. So that is the an idea about these two uh, main type of through hole pins. So, but in Altium sometimes we will face an error. Suppose we will create a footprint for a through hole resistor and we will add two through hole pads in PCB, but after fabrication it will be like this only. So this is mainly because we are not selecting some prop properties in the properties window when we are creating the footprint. So I will show you what are the main things we have to consider before releasing a PCB for a through hole pin. So I will show you now. Suppose this is my PCB board, and I will place two through pins now, through through hole pads now. So the easiest method is, you can see here, place. So first letter is P and there is one underline. So that means for placement, placing anything, you have to press P. That is the shortcut. So I am pressing P. Now I have to press P again. That means I have to place a pad again. So I am again pressing P. So now I placed one, another one. So you can see, and I will enable the 3D view. So both are looking plated through hole, right? So I will change some properties of first through hole pad and second through hole pad. So here you can see the first one properties is in multi-layer. Yes, we need a multi-layer. Means through hole pins are always connected to different layers. So multi-layer, and it is in symbol format, round, and I have added, this is a standard value 0.762 mm and 1.52 mm. That is the hole size, finished hole size will be 0.762 mm, and it will be having an underlaying of 1.524 mm. So that is the idea, and here you can see I have checked this value plated. So that these are the main things. And solder mass expansion I set to rule. I think in last video I have mentioned about this. If you have doubt, you can go and check the previous video about solder mass expansion. And paste mass expansion, it is also set to rule, that is 0 mm. So usually for through hole springs we don't add the paste mass expansion. So the paste mass expansion is mainly for surface mount devices, not for through hole devices, because whenever you open a paste mass expansion during the fabrication time, they will add paste, the solder paste over this through hole pad. So this will be double work, because usually for through hole devices we will not use pick and place assembly. Usually it will be manual assembly after all after we are placing all this SMD components, then only we will place this through hole components. So that is the difference. So this always remember, whenever you create a through hole component, paste mass expansion should be 0, and solder mass expansion you can set to rule, and you have to define the correct value in the design rules. So this is the first through hole settings, and I will go to second settings. Both are same now because I placed manually, so placed from like default through hole pin, through hole pad. Now I will uncheck this one, plated, and I will show you the 3D. So you can see now also both are looks almost same, right? But there is no difference, right? Only a shadow is present here, and here no shadow. So that means this is not a plated hole now. So whenever you release this one, it will be like this only, like this only. It is a non-plated hole now. So usually what will happen when we create a footprint, we will see here it is plated, right? Here they haven't mentioned it is non-plated. So what we will think, okay, we created a footprint based on this plated rule only. It is not in non-plated. Here it is clearly mentioned, right? It is plated. But we are always sometimes forgot to check this. So when you check this, then only it will become plated. Otherwise, it is non remains non-plated only. So always remember this error, this thing. So if in 3D you may not always detect this error. 3D view. Here you can see. Here also we can see this ring, right? This metallic ring. So we will think it is also plated, but actually it is non-plated. Always remember this thing. So whenever you create a through hole pin footprint, always ensure that you have checked this plated checkpoint. So you have to enable this always. Then only it will become a through hole conductive pad. So always plated pad. So always remember this before releasing your board, and always try to avoid this kind of errors so that you can save your time and you can save the money also. That's all about this today's video, guys. So